Hi, this is Chris Lorimore, and we're looking at muscle fatigue during a fatiguing grip test. So we know from previous studies that EMG amplitude increases over time during a fatiguing contraction, and this is due to increased fiber recruitment. We also know that type 2 fibers have a higher EMG amplitude and variability during fatigue than type 1 fibers. So the purpose of this study was to examine EMG activity and how it changes with time during a sustained isotonic and isometric grip. And we expect EMG activity to increase slowly over time. So we first measured maximum voluntary contraction force using a hand dynamometer, and we measured EMG activity during this MVC. From that, the subjects then maintained 25% of that maximum grip force for as long as the subjects could, up to a maximum of 300 seconds. And then peak EMG amplitude and force were recorded every 15 seconds. So we can see how over time, EMG activity actually decreased in both the wrist flexors and extensors from time 15 to time 300, which was unexpected. However, at time 180 seconds, we do see that wrist flexor EMG amplitude decreases as well as its variability. And this mirrors the time that 3 out of the 8 subjects discontinued the grip due to muscle fatigue, who dropped out between 150 and 180 seconds. From previous studies, we know that EMG amplitude and variability is lower in type 1 fibers than in type 2, so therefore we can suspect that those individuals who dropped out had a higher type 2 muscle fiber composition than the individuals who stayed in the entire 300 seconds, who could have had a higher type 1 muscle fiber composition. However, our speculation does not explain the activity of the wrist extensors, and also in order to make any definitive conclusions about fiber composition during a sustained grip test, future studies need to examine the fiber composition of each subject's muscles. So this study is clinically relevant because we as PTs can examine EMG activity to determine if there is fatigue occurring in muscle endurance exercise, and to hypothesize the fiber composition in certain individuals. So PTs can also prescribe exercise to improve certain fiber types. In conclusion, we unexpectedly saw an overall decrease in EMG activity of the wrist flexors and extensors during a muscle fatiguing grip. However, in our wrist flexors, EMG amplitude and variability decreased after the 3 subjects dropped out due to fatigue, making us speculate that the subjects who dropped out had a higher type 2 muscle fiber composition than the subjects who stayed in. But we still can't make any final conclusions about our EMG trends due to our high variability, which could indicate that us first-year DPT students are not perfect EMG recorders or electrode placers.